Welcome everybody. We've been given this interesting question. Integrate 15x to the power of 3 negative 1 divided by x times 15x cubed positive 1 and the differential operator. Now we are expected to integrate this. Now let me take this to be as I. Now this is a challenging question. If you are not in a position to split this, now you can split it in many different ways, but splitting is important. Now how do we split? You have to split in other words, you got to be in a position to write the numerator in terms of the denominator. Only then this question is solvable. If not, it will take ages. So having mentioned that, I want to bring 5x to the power of 3 positive 1 over here in the numerator. So for that, what I wish to do is I'm going to rewrite 15 as, say, 20x to the power of 3, and then I will subtract from 20x to the power of 3 5x to the power of 3. Now when I subtract 5x to the power of 3 from 20x to the power of 3, I'm getting 15x to the power of 3. Fine, but I need to have a negative 1, so for that just place a positive 1 there. Now this is how you write the numerator in such a fashion that you have this term as one of the terms in the numerator. So this is divided by x times 5x to the power of 3 positive 1. This is what we have got. Now what I wish to do is I would now like to rewrite this by algebraic split. In other words, if you have a positive b divided by c, you can write it as a over c positive b over c. So by this can be rewritten as 20 times integral x to the power of 3 divided by x times 5x to the power of 3 positive 1 times dx, followed by negative integral 5x to the power of 3 positive 1 divided by x times 5x to the power of 3 positive 1 times dx. Now this and this gets cancelled, giving you negative integral dx over x. So this is simple, and this and this gets cancelled, giving you 20 times x to the power of 2 times dx over 5x to the power of 3 positive 1. Now let me consider this term. Consider x to the power of 2 times dx divided by 5x to the power of 3 positive 1. So I'm going to let 5x to the power of 3 positive 1 be equal to some t. So if I want to differentiate this, is going to be 5 times 3 times x to the power of 2 times dx is equal to dt. So I've got only x squared dx. So you remove this 5 times 3, 15 to the right side. So x squared times dx is equal to dt over 15. So take this and substitute it here. So this is equal to 20. In place of x squared dx, I'm going to substitute dt divided by 15 over 5x to the power of 3 positive 1 is taken to be as t negative integral dx over x. So this is equal to 5 can divide here 3 times, 5 can divide 4 times, so 4 over 3. Integral of dt gives me ln t, integral of dx gives me ln x. So this is equal to 4 over 3. My t is 5x to the power of 3 positive 1, right? Substitute that, negative ln x. Since it's an indefinite integral, you need to place the arbitrary constant c. So this is the solution. Now most of the times we know in this case that the value of x should have to be positive. So for that case, in this case, since the degree of x is odd power, it is important that we place the modulus sign. So that is the final step. It's an icing on the cake, and it is necessary that we place the modulus. So having mentioned that, this completes the solution for this question. I hope you like this video. Thank you, students. Enjoy it.